Today we are going to describe the mechanism of pyruvate dehydrogenase complex. So pyruvate dehydrogenase complex is a multimeric enzyme which catalyzes the intermediate reaction between the glycolysis and the TCA cycle. That is the conversion of pyruvate to acetyl-CoA. The reaction is pyruvate plus coenzyme A plus NAD plus. In presence of the enzyme pyruvate dehydrogenase complex, that is the PDC, it is the only the irreversible reaction. So the product is acetyl-CoA plus carbon dioxide plus NADH. So from this reaction we can conclude that the substrate of the PDC is pyruvate, and PDC uses two cofactors, actually the coenzyme and the NAD+. But actually PDC, apart from using coenzyme A and NAD+, they can also use FAD, lipoamide and thiamine pyrophosphate as cofactor. So basically PDC is a multimeric enzyme composed of three components known as E1, E2 and E3. E1 is pyruvate dehydrogenase component 1. E2 is dihydrolipoyl transacetylase, and E3 is dihydrolipoyl dehydrogenase. So if pyruvate is getting converted to acetyl-CoA by the help of PDC, how could these enzymes together work so that this reaction can happen? So we are now dealing with the mechanism. So this reaction can be broken down into several stages. Number 1, pyruvate plus TPP, that is thiamine pyrophosphate, it produces hydroxyethyl TPP plus carbon dioxide. So it is the hydroxyethyl TPP plus carbon dioxide. So we first understand how TPP looks like. So the structure of the TPP is so this is the basic structure of TPP. This is the pyrophosphate portion. This particular ring is known as thiazolidine ring, and this ring is known as aminopyruvidine ring. So it consists of three portions basically. So in this particular reaction we only require this ring, that is we can describe this one as R and this part as R dash. So we can rewrite this thing. So this is the pyruvate and this portion is denoted as So this particular portion is denoted as R, and this portion is denoted as R dash. This is the basically the area where the reaction will occur. So what will happen? This hydrogen will be taken up by the carbon to produce COH. This is the first carbon, O minus double bonded O. This is the last carbon, CH3. So by accepting this hydrogen, there will be a bond between C and C. So this is the CC bond, and the remaining portion there will be a CH3 group. So this is known as addition compound. Now what will happen? We have a negative charge here. If this charge shift to that position, so this CC bond will be broken down. In that case, that CC bond will be broken down, and this bond should be deposited here. This bond will be broken down. So actually what will happen? Carbon dioxide will be eliminated, and the product is COH, CH3, double bond C, single bond nitrogen, then all other as they were originally present. Okay, so this is known as actually hydroxy ethyl TPP. We can rearrange this structure by shifting this bond to here. In this case, the product will be looks like CH3. There will be negative charge, single bond C. Now once again double bond N plus R, and the remaining portion. This is also known as the hydroxy ethyl TPP. So the first reaction, pyruvate plus TEP equal to hydroxyethyl TEP plus carbon dioxide. Here is the carbon dioxide and here is the hydroxyethyl TEP. This is the structure of pyruvate, and that one was TPP. Okay. So now the second reaction, step 2. Step 2 is hydroxy ethyl TEP will join with lipoamide. So how lipoamide looks like? Lipoamide is SS, CH2, CH2, CH, and there will be R, and there is a bond. So this is the lipoamide, and we have the hydroxyethyl TEP here. So hydroxyethyl TEP is OH, C minus CH3, C double bonded N plus. So now what will happen? This hydrogen will be accepted by the sulfur, so that SS bond will be broken down. So SH. So this S will take up that hydrogen to form SH. So the remaining portion is CH2, again CH2, CHR, and now we have a sulfur, and sulfur will carry this CO and CH3 group. This is the hydroxy ethyl group. So that means the product will be C double bonded O, CH3. So this is known as acetyl group. So acetyl lipoamide. So acetyl lipoamide plus the remaining portion of the TPP known as carbanion of TPP. So the product is actually acetyl lipoamide plus carbanion of TPP. This reaction is also catalyzed by pyruvate dehydrogenase component 1, that is known as E1. So now we have this acetyl lipoamide which contains this acetyl group. We need to produce acetyl CoA. Remember in the first reaction where we need to convert pyruvate to acetyl CoA, right? Carbon dioxide has been produced by the first reaction. This is the region where carbon dioxide has been produced already. Now we need to produce acetyl CoA, and we have the acetyl lipoamide where acetyl group is there. So now we need to add coenzyme A. Look at the first reaction. Here CoA is there, so we have not used CoA at this point. Now we can use this CoA. So this is the second reaction, third reaction basically, where we have acetyl lipoamide plus coenzyme A, an enzyme called dihydrolipoyl transacetylase. Transacetylase means transfer of acetyl group. So we have this is the acetyl lipoamide and this is the coenzyme A. So this acetyl group will accept the CoA to form CH3 C double bond arrow SCOA, known as acetyl CoA, and therefore this hydrogen will be accepted by the sulfur to produce dihydrolipoamide. This reaction is catalyzed by the E2 enzyme. E2 is known as dihydrolipoyl transacetylase. So here the acetyl group will be transferred to coenzyme A to produce acetyl CoA. So the product is acetyl CoA plus dihydrolipoamide. In the first reaction, what you can see, we have already used the pyruvate coenzyme A, but we never use NAD+. So we should use NAD+ here. Why? Because we need to convert this dihydrolipoamide to lipoamide back again. So this is the last reaction. We have the dihydrolipoamide. We can use NAD+. NAD+ will accept this to hydrogen. Therefore, normal lipoamide will be produced once again, and the product is NADH plus H+. So this is the lipoamide. This particular reaction is catalyzed by dihydrolipoyl dehydrogenase. Any reaction where NAD FAD we are using NAD or FAD, then there must be a dehydrogenase enzyme. So this reaction is dihydrolipoyl dehydrogenase catalyzed reaction. So this lipoamide can be used further. So now we have a summary. Now we have a summary, that is pyruvate. When the pyruvate is getting converted into carbon dioxide, then TPP will be converted to hydroxyethyl TPP, that is CH3CHOH TPP. This reaction is catalyzed by E1 enzyme. When TPP is going back to hydroxyethyl TPP is going back to TPP, in that case lipoamide, which is normally can be denoted by this type of reaction, can be converted again in the presence of E1 to SHLS C double bonded O CH, that is acetyl lipoamide, right? This acetyl lipoamide can be converted to dihydrolipoamide when we are using CoA in the presence of E2 enzyme to get converted to acetyl CoA. Now the last remaining reaction will be catalyzed by FAD that can accept this 2 hydrogen to form FADH2, and this reaction can be again catalyzed by E3, which can accept this 2 hydrogen present in FADH2 to form NADH plus H plus. So this is the overall reaction of pyruvate dehydrogenase complex with respect to the mechanism. Hope that will be good for you.